Hi everyone, myself Harshita S from Sri Venkateshwara College of Engineering. My subject is about computer graphics and visualization, and the topics that I'm discussing in this subject are 2D pipeline, 3D pipeline, and color models. So let us see what is 2D pipeline. So 2D viewing pipeline. So the mapping of a two-dimensional word coordinate scene description to device coordinates is called a two-dimensional viewing transformation. This transformation is simply referred to as window to viewport transformation or the windowing transformation. We can describe the steps for two-dimensional viewing as indicated in the below figure. So once a world coordinate scene has been constructed, we could set up a separate two-dimensional viewing coordinate reference frame for specifying the clipping window. To make the viewing process independent of the requirements of any output device, the graphic system convert object descriptions to normalized coordinates and then apply the clipping routines. So systems use this normalized coordinates in the range from 0 to 1 and others use a normalized range from -1 to 1. At the final step of these viewing transformations, the contents of the viewport will be transferred to the positions within the display window. So clipping is usually performed in normalized coordinates. These allow us to reduce computations by first concatenating the various transformation matrices. So the diagram that we are discussing here is about the MC that is connected to the construct world coordinate scene using the modulate coordinate transformations, which is giving to the world coordinates, that is convert world coordinates to viewing coordinates. Next, we see that is viewing coordinates to transform viewing coordinates to normalized coordinates. Next to the normalized coordinates, that is map normalized coordinates to device coordinates, that is to the direct coordinates. First, we need to consider only the rectangular viewports and then the clipping window that is illustrated in the below figures with respect to the world coordinates as well as the viewing coordinates. So the mapping of a two-dimensional world coordinate scene description to device coordinates will be called as a two-dimensional viewing transformation. So this transformation is simply referred to as the window to viewport transformation or the windowing transformation. So we can discuss or we can describe the steps for two-dimensional viewing as indicated in the figure. So here in the figure, it is given as the world coordinates as well as the viewport coordinates. So in the world coordinates, there's given a picture inside the clipping window and outside the clipping window within the coordinates XW minimum, XW max, and YW minimum and YW max. So after performing the clipping, the world coordinates will be portrayed and it will be shortcutted into viewport coordinates that will be inside the window, and the outside of the window will be clipped off. That is, will be given within the coordinates YV max, YV minimum, XV minimum, and XV max. So once the world coordinate scene has been constructed, we could set up a separate two-dimensional viewing coordinate reference frame for specifying the clipping window. So once we know about the 2D viewing pipeline, now we'll go to the 3D viewing pipeline. So the steps for computer generation of a view of 3D scene are analogous to the process of taking photograph by a camera. For a snapshot, we need to position the camera at a particular point in space and then need to decide the camera orientation. Finally, we will snap the shutter. The scene is cropped to the size of window of the camera and the light from the visible surfaces will be projected into the camera film. So let us see how this 3D viewing pipeline will work in the form of some coordinate positions, that is modeling coordinates that will be given as modeling transformation that will get modified into modeling coordinates, then to the viewing transformation, then finally to the viewing coordinates. That will be giving rise projection transformation, projection coordinates, workstation transformation, and device coordinates. Next, we'll see what are projections. So once the world coordinate description of the objects in a scene are converted into the viewing coordinates, we can project the three-dimensional objects onto the two-dimensional view plane. There are two basic projection methods. So that is nothing but the parallel projection. So in parallel projection, coordinate positions will be transformed to the view plane along the parallel lines. Next one is the prospective projection. So in this prospective positions, the lines will be transformed into the view plane along the lines that coverage to a point called that is been called the projection reference point. So this projected view of an object will be determined by calculating the intersection of the projections line with the view plane. A parallel projection preserve relative projections of the object, and this is the method that is used in drafting to produce scale drawing of the three-dimensional objects. So accurate view of various sides of three objects is obtained with parallel projection, but it does not give a realistic appearance of 3D object. A perspective or prospective projection, on the other hand, produces realistic views but does not preserve relative proportions. So projections of distant objects from view plane are smaller than projections of objects of the same size that are closer to the projection place. So what is parallel projection in depth? So we can specify parallel projection with projection vector that specifies the direction of projection plane. When the projection lines are perpendicular to view plane, the projection is orthographic parallel projections. If projection line are not parallel to view plane, then it is oblique parallel projection. So the another important topic that we are discussing is all about the color models. So what is a color model? Any method for explaining the properties or behavior of color within some particular context is called a color model. So here is a basic diagram of how color model will be executed with RGB color model. Next, according to what is RGB color model? So according to the Tristyllimus theory of vision, our eyes preserve color through the stimulation of three visual pigments in the cones of retina. One of the pigments is more sensitive to light within a wavelength of about 630 nanometer, and another has its peak sensitivity at about 530 nanometer. And the third pigment is most receptive to light within a wavelength of about 450 nanometer. So the three primaries, red, green, and blue, which is referred to as RGB color model. We can represent this model using the unit cube defined on RGB axis as shown in the figure. The origin represents black and the diagonal opposite vertex with coordinates 1, 1, 1, which is white. The RGB color scheme is an additive model. Each color print within the unit cube can be represented as weighted vector sum of the primary colors using the unit vectors R, G, and B. So C of lambda is equals to R, G, and B, which is equals to RR plus GG plus BB, where parameters R, G, and B are assigned values which are in the range of 0 to 1.0. So the CMY and CMYK color models. So the CMY parameters. A subtractive color model can be formed with the three primary colors, that is cyan, magenta, and yellow, and unit cube representation for the CMY model will be presented with the help of the diagram that is being given here. It's just having an extra color of grayscale as well as the magenta and cyan. So in the CMY model, the spatial position 111 represents black because all components of the incident light are subtracted. The origin represents white light, and equal amounts of each of the primary colors produce shades of gray along with the main diagonal of the cube. A combination of cyan and magenta ink produces blue light because the red and green components of the incident light will be absorbed. Similarly, a combination of cyan and yellow ink produces green light, and a combination of magenta and yellow ink yields red light. The CMY printing process often uses a collection of 4 ink dots which are arranged in a closed pattern, somewhat as an RGB monitor uses 3 phosphor dots. Thus, in practice, the CMY color model is referred to as the CMYK model, where K is the black order parameter. One ink dot is used for primary colors and one ink dot is the black. Thank you.